The graph of a line in the xy plane has slope 2 and contains the point with coordinates of 1 and 8. The graph of a second line passes through the points with coordinates of 1 and 2 and 2 and 1. If the two lines intersect at the point AB, what is the value of A plus B? This problem gives us two lines, or at least some of the dimensions of these two lines, and asks us to find the point of intersection with the coordinates of A and B, standing for the coordinate x and coordinate y, and then add the value of these dimensions. Let's try to visualize how it looks approximately. So one of the lines has all the dimensions written out. As we know, to draw a line, we only need 2 points, and we are provided those 2 points with the dimensions of 1 and 2 and 2 and 1. So there'll be that line that goes at some point on the plane in a certain direction. Then there is another line, and we're only provided 1 point and a slope, but it goes in a certain way, and at some point these two lines intersect. The main insight here is that this point of intersection should work out for equations representing both lines. So let's start. Since the point of intersection, the one that we're asked to solve, should fit both lines, let's focus on defining the linear equations for each of the lines. And let's be reminded that the equation of a line has the form of y equals slope times x plus y-intercept. Let's also be reminded that slope is calculated by dividing change in y by change in x, or mathematically it's called also delta y or delta x. Let's start with the first equation. We are provided 1 point with the coordinates of 1 and 8. In this case, 1 is the x coordinate and 8 is a y coordinate, and we will need to use this in our equation. And the slope of 2. With 3 of the pieces provided, we can now put together an equation of 8 replacing y equals 2 for slope times 1 for x plus y-intercept, which we will represent with the letter c. To calculate the unknown c, we would need to neutralize the addition of 2 times 1. For that, we'll subtract 2 from both sides to maintain the equality, and we get c equals 6. So our final look is y equals 2x plus 6. This is the equation for the first line. Now we will try to construct the equation for the second line. With 2 points of 1, 2 and 2, 1, we can calculate the slope, which is an important part of the equation. And as we already discussed above, the slope would equal change in y over change in x. And change in y is going from 2 to 1, which is minus 1. And change in x is going from 1 to 2, which is a positive 1. This means that our slope equals to minus 1. So now let's use the first of the 2 points to put together a linear equation. So for y we'll use 2, for slope we'll use minus 1, and for x we'll use 1. And once again, for y-intercept, we'll just use some replacement, a letter c. To isolate c, we'll use mathematical manipulation and add 1 to both sides of the equation. And our result is 3. Since c is the same as y-intercept, it was just a replacement for mathematical purposes, our y-intercept equals to 3. So now we can write down our equation as y equals -1 for slope times x plus 3 for y-intercept. Since -1x is the same as -x, let's write it down in this form. Now that we have two equations representing both lines, we know that the point of intersection can be described by both of these equations. So that y dimension of the point of intersection can be represented by 2x plus 6 and also by -x plus 3, which means that 2x plus 6 is the same as -x plus 3. Let's use mathematical manipulation and bring x to one of the sides. Let's neutralize -x on the right-hand side. And we'll do so by adding x to both sides of the equation. And once we do so, let's also move the +6 from the 2x side of the equation by subtracting 6. As a result, we get 2x plus x, 3x equals 3 minus 6 equals -3. Right now, we need to neutralize the times 3 part. So we'll just divide the left-hand side by 3 and the right-hand side by 3 as well. And what we get is x equals -3 divided by 3, or -1. Now we have the x-coordinate for the point of intersection. Let's find the y-coordinate. We could use either of the two equations. Let's use the one above, y equals 2x plus 6. In this case, we'll replace x with -1. And what we get is our y equals to 2 times -1 plus 6. We do simple operation here. It means y equals 4. So our point of intersection has the coordinates of -1 and 4. -1 for x and 4 for y. The question asks us to add these two values. So -1 plus 4 equals 3. And this is our final answer. Let's mark answer choice B.